right, we got some radical equations now. We've done adding, subtracting, simplifying, multiplying, dividing radicals. Our last thing to do with radicals is solve some equations involving radicals. So I have a procedure here for you, and I'm not gonna bore you with that. But basically, here's what's gonna happen. You're gonna see radicals in an equation. Obviously, it's an equation when you have an equal sign. And to solve them, what you're gonna want to do is get a radical by itself on one side of the equation, so you can isolate it basically. We're going to, in this case, to get the radical all by itself, the radical x, we're going to add 6 to both sides. Add 6, and I'll start going a little quicker as we go through here. So we're left with the square root of x equals 10. And what we're going to do is the inverse operation. Like when you want to solve for x and its multiplication, you divide, you do the opposite. When you have addition, you do subtraction in equations. We do the opposite operations. The opposite of a square root of x, the opposite of that is a square. So what we're actually going to do is we're going to square this, because when you square a square root, it cancels out basically, and you get just x. But if you can't just square one side of the equation, you have to square both sides. So we're going to square this as well. So we square the square root of x, and that's just x. That's just plain old x. Because it's x squared, but it's the square root of x squared, which is just x. And then that's 100. So x equals 100. But we do have to check to make sure it works. So we'll do a little check here. I'll just put CK for check. Square root of 100 is 10 minus 6 equals 4. 4 equals 4. And that does check. Okay, so I just plugged in 100 here. 100 square root is 10. 10 minus 6 is 4. That does work. So we would write a solution set with the answer 100. So this one here, the square root of x equals, now we would subtract 6, so we'd get negative 2. 4 minus 6 is negative 2. Now we square both sides. X equals 4. And then we have to check. Square root of 4 plus 6 equals 4. 2 plus 6 equals 4. Oh, no, it does not. 2 plus 6 does not equal 4, so therefore x does not equal 4, and there is no other possible answer. So that means there is no solution to this problem. You just draw the braces with nothing in it. That means it's the empty set. There is no answer. There is no solution. So there's no number where you could take the square root and add 6 and get 4 for an answer, which should make sense, because when you take the square root, you have to get a positive number. There's no positive number plus 6 that will equal 4. Okay, so there could be no answer for that one. Cubic roots, same thing. Cubic root of x equals negative 2. This time, instead of squaring it, we're going to raise it to the third power, because the opposite of a cubic root is a cube. So we're going to raise it to the third. All right, so that cancels out, leaving us with just x equals, and this is negative 8. X equals negative 8. Now we have to check. We have to check the cubic root of negative 8 plus 6. Does that equal 4? Well, the cubic root of negative 8 is negative 2 plus 6. Again, if you don't know that, you can put that in your calculator. Equals 4, and of course 4 equals 4, so yes, that does work. So my solution here would be negative 8. We would put that in our braces. And how about this one? Well, we'll get 2 radical x by itself. Add 1, you get 8. Now, you could divide by 2 here if you want to. You could divide by 2, but I want to show you how it works without doing that. As long as you have the radical term by itself, you're okay. You could square this right here. So if you do decide to square it right here, you got to be careful. The square root of x squared is just x, but you have to do, this is a regular 2. So 2 squared is actually 4. This is 4x. 4x. And this is 64. So then you just divide by 4, and you get 16. All right, so now we have to check to make sure 16 works. Let's kind of squeeze it over here, check. 2 square root of 16 minus 1. That's 2 times 4 minus 1. That's 8 minus 1. That's 7, and that is what we were supposed to equal. 7 equals 7. So yes, 16 does work. So again, you have to check for erroneous solutions. You don't always get solutions that work for these. All right, so a little trickier now. These examples here, example 2, we're going to throw some binomials in, and you're going to have to do some work here. It's not going to be that bad. Again, we have the radical all by itself, so we're just going to go right here. We're going to square both sides the way it is. Square both sides. When you square radical 2x minus 3, the square cancels out the radical, and you just get 2x minus 3. So instead of just x, you get a binomial, 2x minus 3. And that equals 121. You have to square the 11. So 2x equals 124, add 3, and then divide by 2, x equals 62. And that does check, so I'm just going to put that in there. I'm not going to do the checks. I'm not going to do all of the checks on this video because then the video is going to be crazy long. But you know checking is just plugging it into the original to see if it works. Let's just do this one. 62 times 2 was 124. Minus 3 is 121. The square root of 121 is 11. So that's why that works. So we're going to cube both sides here. Cube both sides. Raise it to the third. That cancels out there, and you're left with just 6 minus x. Negative 3 raised to the third is negative 27. Subtract 6 from both sides. If negative x equals negative 33, x must equal positive 33. And it does work. 6 minus 33 is negative 27, and then the cubic root of negative 27 is negative 3. So it does check. So I'll go ahead and put 33 in our solution there. This one here, you're going to want to isolate the radical, so we're going to add 9 before we do anything. Negative 3. Okay, so now I need to square both sides because we're back to a square root. X plus 5 equals 9. Subtract 5x equals 4. Let's see if that works. 4 plus 5 is 9. The square root of 9 is 3. 3 minus 9. 3 minus 9. That's not negative 12. 3 minus 9 is not negative 12, guys. So that does not work. So there is no solution. We got the empty set again. There is no solution for C. Here we have a radical on both sides. That's okay. That's okay. Square both sides. All right, trying to cover all different scenarios you might see. They're really not bad. Radicals drop out on both sides. Subtract 3x, add 7. X equals 16. And that one does work. You plug it into both sides, you will get the same radical. This one here, we're okay as long as it's a single, it's connected by multiplication, so that's okay. We can square this. Actually, we're going to raise to the third. Raise to the third. So this one now, be careful here. 3 to the third. That's not under the radical, so that's actually got to get raised to the third. 3 to the third is 27. And then this is going to stay x plus 2. See what we did there? This cubic root cancels out, but it's still x plus 2. So that needs parentheses. 12 to the third is 1,728. All right, so I have 27x plus 54 equals 1,728. Subtract 54 from both sides. And that gives me 1674. And then I divide by 27. And that gives me 62. And 62 does check. You can put 62 in here. You get cubic root of 64. Cubic root of 64 is 4. 4 times 3 is 12, which is what it was supposed to equal originally. All right, square both sides. what do I get here? X squared plus 8x equals 9. Oh boy, now I have a quadratic. That's okay. That's okay. X squared plus 8x, going to get it equal to 0. Minus 9 equals 0. Now I'd factor minus 8 minus 1. No, that's not true. Plus 9. Plus 9 minus 1. Plus 9 minus 1. X equals negative 9 and x equals 1. So now you got to check both of these to see if they work. And negative 9 squared is 81 minus 72. That's 9. Radical 9 is 3. 3 equals 3. That does work. And 1. Again, you would write this out if you're not sure. 1 squared is 1 plus 8 is 9, and we get 9 again, so that does work. So they both do work. So my solution set's going to be negative 9 and 1. Solution set will include negative 9 and 1 in it. All right, these here are just going to get progressively a little trickier. Now, again, still, we got the isolate of the radical, okay? We're going to square both sides, but now look what happens. When you square this side, you're going to get a binomial squared. So this one is just x plus 5, like it was on the other examples. But here, it's x minus 1, x minus 1. It's x minus 1 squared. There's no radical to cancel out the square. So you have to multiply x minus 1 times x minus 1. Well, we should be able to do that by now. We've been doing that all year. So it's x squared minus 1x plus 1. X squared minus 2x plus 1. This is a quadratic again, so we're going to get it equal to 0. I'm subtracting x, giving me negative 3x. I'm subtracting 5, giving me negative 4. We should be able to do this stuff in our head by now. These quadratics, we've been doing these for so long now. Hopefully we're getting good at them. X minus 4x plus 1. X minus 4x plus 1 works. So x equals 4 and negative 1. And negative 1 doesn't work. Negative 1 plus 5 is 4, square root is 2, and negative 1 minus 1 is negative 2. So negative 1 does not work. My solution is just 4. 4 does work. 4 plus 5 is 9. Radical 9 is 3. 3 equals 4 minus 1. Yes, it does. 3 equals 3. So if you check that out, 4 works. Negative 1 does not work. Here I want to isolate. Okay, so but I have to subtract the x over. 6 minus x. 6 minus x equals radical x. I needed to get my radical by itself so that I can now square both sides. That's a square. All right, so we have 6 minus x, kind of like how we had the last one there. We had the binomial squared. And then the radical is going to cancel evenly, just x. 36 minus 6x plus x squared minus 12x plus 36 equals x. Bring that x over. All right, so it's going to be x minus 9, x minus 4, 9 and 4, and the 9 doesn't work, so it's just going to be 4. Just going to be 4. The 9 doesn't work. 9 plus 3 is not 6. 9 plus 3 is not 6. 4 plus 2 is 6. All right, so you plug in the 4, it works. All right, another one here, 3 plus x. Getting the radical by itself. You can leave the 4 along with the radical. That's okay. Square. Got to square both sides. 9 plus 3x plus 3x plus x squared, when you square that out, equals 16x. Careful there. 4 squared is 16. Radical x squared is just x. Get it equal to 0. X squared. I have 6x plus 9 equals 16x. Now bring it over. X squared minus the 16x, so minus 10x plus 9 equals 0. X minus 9x minus 1. 9 and 1, they both work. They both will check out. 4 times 3 is 12, minus 9 is 3, and then 4 times 1 minus 1 is 3. So those both work. All right, last two here. These are going to involve a couple different squaring steps. You'll kind of see how this works. We have this all by itself, so that's good. So we're going to square this. But here, you can't just square these individually. We kind of talked about that in another lesson. So you have to square the entire side. So now it's 3 plus radical x times 3 plus radical x, which we know how to multiply, but we got to actually do it. So that just is a little extra step there. And this is just x plus 81. So you have to actually multiply this out. 9 plus 3 radical x plus 3 radical x plus radical x times radical x is just x, because it's radical x squared. All right? Now, subtract x from both sides, which is nice because the x goes away. Subtract 80, well, let's leave that alone. Leave that alone. All right, so 9 plus 6 radical x equals 81. So 9, because this is 6 radical x here. Now, I have a new radical equation from my original radical equation. So I'm going to isolate this radical now. Subtract 9. 6 radical x equals 72. Now, square both sides again. All right, so I get 36x equals 5184. Divide by 36 and you get 144. X is 144, and it does check. One more of these. Now this one's ugly because you got no choice. You got to bring a binomial over with the 4. So subtract, and this is as bad as it could get. Subtract radical x plus 5. So we have radical x minus 3 equals 4 minus radical x plus 5. Now, square both sides. This side's easy. That's just going to be x minus 3. That's easy. This is not. You have to make it 4 minus radical x plus 5 times another 4 minus radical x plus 5. Because it's like a binomial. It's like a binomial inside of a binomial. So that's kind of ugly. I'm getting writer's cramp. I don't know about you. So let's see. X minus 3. There's going to be 6. You got to distribute this out. 4 times 4 is 16. 4 times negative radical x plus 5 is negative 4 radical x plus 5. And then inside here, these two here, it's another negative 4 radical x plus 5. And then plus radical x plus 5 times radical x plus 5 is just x plus 5. All right, so what do I have? I have 21. So you have x minus 3. 16 and 5 is 21. Plus x minus 8 radical x plus 5. All right, the x's drop out because I have x on both sides. Subtract 21, giving me negative 24 equals negative 8 radical x plus 5. And now I can square both sides. Again, squared, squared. All right, so now I have 576 equals 64 x plus 5. And that's going to be 64x plus 320 equals 576. Subtract 320, 64x equals 256. And then divide by 64, x equals 4. A lot of answers of 4, right? And it does work. 4 minus 3 is 1. 4 plus 5 is 9. 1 plus 3 is 4. All right, so that does check out. 4 would be your final answer there. All right, I know that's crazy. You won't have to do one. Not going to have too many of those, but we will be ready for that in case they ask us that. All right, see you in class tomorrow.